It's an interesting story. Up until Bioinnovation, there were only, that we're aware of, there were two patents having to do with the automated focusing and scanning of pathology slides. The first one we're aware of is from Hamamatsu some time ago, and then the next one from Aperio, which is Leica. And all the scanning, whole slide scanning that we're aware of has to either use those, has to license those patents or use those patents. By innovation, Yin invented a new system that was different enough to become patentable. And it's so novel, the core technology allows the system to predict, to actually find what the curved surface is, the true surface of the microscope slide. And by mapping that out, the scanner can move very fast because the Z-axis knows where the next step it ought to be. And so the scanning takes place up to 70 times faster than the current state of the art.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Hi, everyone, and welcome to the podcast. Today, my guest is Don van Dyke, the Business Development Officer of Bioinnovation Biotech. And Bioinnovation's goal is to use innovative technologies to improve digital imaging in pathology. Hi, Don. How are you today?
I'm doing great. It's great to see you.
Good to see you, and thank you so much for joining me on the podcast. And let's just start with a brief introduction. Tell the listeners about yourself and your company, Bioinnovation.
Yeah, I began my career a long time ago selling laboratory products into pathology labs and all clinical laboratories. 70,000 products that could turn an empty building into a clinical laboratory. Did that for 8 years with American Hospital Supply, and then joined a startup company in quantitative digital image analysis called BioImage. And we were acquired by a couple of different companies. We became dominant in proteomics and certain areas of genomics, image analysis. While we were owned by Millipore, I put together a partnership and bought BioImage from Millipore and ran that as CEO. I was with them for 11 years, last 3 years as CEO. Eventually, that company merged with another company and went public on the NASDAQ. Then I spent 5.5 years in artificial intelligence with the cloud pharmaceuticals, where we did target-based drug design using AI from Duke University, local here to where I am in Raleigh, North Carolina. And then I discovered just about a year ago, came across Bioinnovation, which combines pathology, digital image analysis, and artificial intelligence. I'm the business officer. The company was founded and primary owner is Yin Yufeng, who's located in San Diego. And he had, the founding of the company is really interesting, but he is a technical person, very excellent engineer, has put out laboratory instruments successfully in the past. I've always been on the business side of scientific instrumentation, so we fit together that way.
So you say the company's main location is in San Diego?
Yes, the company Bioinnovation Biotech Incorporated was founded in 2017 in San Diego. It's registered in California. Yin, of course, is from China, from Suzhou, and has business interests in Suzhou. And also, that's where most of the R&D and production and all that sort of thing takes place for Bioinnovation, but it's an American company.
Mm-hmm. So what does Bioinnovation offer? What are your products? Or services, or both?
We have a novel, innovative whole slide imager for pathology slides. And the reason why it's innovative has to do with the core technology that's been patented by Yin that allows extremely high speed, high magnification scans to take place in a short period of time.
So Bioimager is a scanner, right? It's a whole slide scanner, or does it scan other type of specimen as well?
Whole slide or large slide scanners, but the Bioinnovation CSFA 800 is designed only for pathology use.
Okay, and you say it's high speed. How high is the speed? How much faster is it than the other products, the other whole slide scanners that are on the market?
It's an interesting story. Up until Bioinnovation, there were only, that we're aware of, there were two patents having to do with the automated focusing and scanning of pathology slides. The first one we're aware of is from Hamamatsu some time ago, and then the next one from Aperio, which is Leica. And all the scanning, whole slide scanning that we're aware of has to either use those, has to license those patents or use those patents. By innovation, Yin invented a new system that was different enough to become patentable. And it's so novel, the core technology allows the system to predict, to actually find what the curved surface is, the true surface of the microscope slide. And by mapping that out, the scanner can move very fast because the Z-axis knows where the next step it ought to be. And so the scanning takes place up to 70 times faster than the current state of the art.
So what's the time for 1.5 centimeters time wide, 1.5 centimeters? This is like the standard measurement of whole slide imaging. How fast does it scan?
Yeah, 20 seconds, something like that.
Okay, that's fast.
Let's go in a different direction. Let's take it out to the end. Can do a whole slide image of a peripheral blood smear at 100x oil in 3 minutes or less.
100x in 3 minutes. Okay, that is fast indeed.
Yeah, it's the whole slide.
First of all, I'm not aware of any other scanner that does 100x. Usually, there are some?
Yeah, but they take a long time, from what I'm told.
Mm-hmm.
That opens up a whole new way of looking at whole slide imaging, and we're exploiting and teaching about what that can mean to pathologists about the accessibility of high magnification, high speed imaging.
But you have also the 20x and 40x magnification in the scanner as well.
Yeah, it's quite a compact system. Fits on a bench top, but it has a 5-place nose piece.
Mm-hmm.
20, 40, 60, 80, 100 oil. They're standard objectives, so you can change those around. But the usual configuration is 20, 40, 60, 80, and 100.
Okay. And so what is your mission with this product? Where are you going with this, except that it's faster?
Integrating high speed into high magnification is really our mission. But there's a secondary mission that provides data, that provides image data, but we're also committed to providing answers immediately on the fly. So there's a bit of a breakthrough with this very high magnification, high scanning capability, but we also incorporate AI hardware right into the scanning platform, and we actually do deep learning calculations on the fly while the scan is taking place, and deliver answers immediately. High speed, high magnification, and immediate results.
So you have it's image analysis of the slides that you're scanning inside of the microscope. And this is your proprietary image analysis, or do you have an open API to be able to use other software from other vendors?
This is where Yin and I really agreed without ever knowing each other. I came from AI for 5.5 years, and it's my opinion and the opinion of others I work with that AI will become ubiquitous. Okay, it's going to become like an Excel spreadsheet, and so encouraging AI to be ubiquitous is the right direction strategically to go, in my opinion. Therefore, the image files are open architecture. Frankly, proprietary architectures for images is stupid.
Which is the case in pathology. Everybody has their own proprietary format, unlike radiology.
Yeah, it's simply greedy, and there's no reason why a scanner can't return any image file format that you ask it for. 11 years of bioimage, you can put out any format that you want. Let's put out format that the users would like to have. So we let them choose which image file format, their open architecture.
And this is a capability of the scanner. You can choose the file output you want?
Yeah, you can choose JPEG, you can choose TIFF, you can choose SBS. It really is trivial. It should be trivial for everybody.
Okay, and then it seems like such a big deal. Everybody is making their own file format, and that's very confusing, especially for downstream analysis for the computer scientists. Not
any more for the users because you can download any viewer and you have viewers that support many file formats. But what I have heard from computer scientists that are doing AI, that are designing algorithms to analyze, they have to troubleshoot first if they have images from different sources to make a common denominator for those.
Well, okay, let's look at the electronic health record track record. Okay, and it's a similar mindset where the early deliverer of electronic health records wants to keep their customer locked in and not allow interoperability with other systems in order to increase the short-term revenue and the profitability of the firm. That actually is very noxious towards the ecosystem of electronic health records, where we see in other disciplines where interoperability of data types is accepted. And in EHR, it's moving heaven and earth to get interoperability, and it's preventing innovation from taking place. And it's the same mindset that goes with scanners that want to lock you into the file formats. We're a little tiny company, but at least we're doing our part to make the images open and available. And the same thing with the AI architecture. So we believe that AI, or deep learning, I should say, will become ubiquitous, particularly in image analysis and management. And therefore, we certainly provide an onboard solution. But if you like part of what we have and you want to add to it, if you like none of what we have, you want to change, you want to do your own, that's fine. We'll enable that group or that organization to do the training sets, to run them on the system, and to have their own particular version of deep learning that they want to use, not what some company has told them that they want to use.
I'm asking because many people already have image analysis solutions that are working for them, some deep learning based, and I was wondering if that would be possible to integrate with your system, and from what you're saying, it is possible. So 2 quick questions. How big are you, and how many slides fit in the scanner at the same time?
So all told, worldwide, we're somewhere between 45 and 50 employees. We are kind of lean on the business side and the executive side here in the States, but that's the size of the company. So the current systems that we have out right now are 2-slide cassettes. So you can swap out 2-slide cassettes in that format. By the end of December 2020, we'll have a 30-slide cassette system, auto-loading system that's being, it's actually up for FDA approval in China, CFDA right now. And then in 2021, we expect to go to in the 1,000 to 1,200 slide loader.
Oh, wow. That's a lot. So who are your customers at the moment? Who are your current customers, and also who are your target customers?
Right now, we're in evaluation in a clinical hematopathology section that Newsweek ranks as one of the top 5 hospitals in the world, and that evaluation has been going well. They're seeing that we can do things that haven't been done before, and there's the gate. There's a gate right now. If an organization in pathology group or a hospital system wants to go completely digital, there's a gate, because cytology and hematology pathology or hematopathology require higher magnifications than are generally available in the standard scanners. So what we're seeing is the high mag and the high speed can fix that problem for organizations that want to go fully digital. And so that's where we're focusing first.
That was exactly what I wanted to ask next. Because you have the technology that predicts the surface, it's less data consuming to do the Z-stack. You're just going on the surface of the slide.
Right.
You don't have to do plenty of Z-stacks at different levels.
Right.
You probably can, but you don't have to.
Exactly.
You have a high quality image from one scan.
Exactly. Let's do the absolute best job we can on the first scan to get, and with a peripheral blood smear, it's not going to be thick, okay? So do that as well as you possibly can. But if you want to do Z-stacks, of course, we can do Z-stacks. And we also have some nimbleness about how to handle images. There are ways to do Z-stacks and reduce the image size and retain the information and the detail of the image. There are ways to scan at very high magnification and still keep a manageable file size and retain all the information and detail in the images and so forth. So it's exciting what you can do if you apply all of the tools that are available.
So where is your ideal place to be? Let's say in 5 years, you have the company fully developed, fully functioning. Where would you want to see your scanners? Everywhere where scanners are there at the moment, or you have a little bit more niche approach to that?
While the platform has a really compelling envelope, it's benchtop. It can be self-installed. It doesn't require technicians to come and self-install, but it has precision down to 0.2 microns in the XY platform. So, and you can do 20, 40, 68, and you can do all those magnifications. Yeah, it could be used widely. There are certain disciplines, though, in pathology where the current market leaders have earned their market leadership position by doing things about enabling workflows, about working well in a production environment, where many clinical pathology laboratories really are a production environment, particularly in the for-profit labs. And they do a really good job of being the Amazon, crank out the product as quickly as you can at as low cost as you can. The opportunity for us would seem not to be to go directly against that, particularly at the size and development level that we are. So we're going to the places where people need us, that we do things that people cannot do so far. That's our beachhead.
Mm-hmm. Okay. And probably not for the hardware, but for the software inside, you must at some point work with pathologists or have a vision how to work with them. Maybe you can tell me about it.
Right, so we have several AI, I should say, deep learning computer vision models that we've already developed. Those have all been developed in Asia with the deep cooperation of pathologists and practicing laboratories in Asia. Right from the beginning, the development of our peripheral blood analysis, the bone marrow, the cytology, and now we're working on certain cancers. That's the R&D is primarily taking place in Asia with local pathologists there. Since I've been here, we've begun to make relationships with some leading universities and cancer centers in the United States and in Canada, where we're partnering with some thought leaders to have them evaluate and publish and give their inputs to us about what the particular strengths are of the platform.
And what were the problems that you encountered while developing your offer and while making this device? Something that you had to overcome that you did not expect. You've been in the industry for a long time, plenty of hurdles, but was there anything that was unexpected that you had to pivot and do something differently?
Personally, for me, as a manager, I'd been away from pathology for some time, so I had to catch up to what the current environment is. That took some time. It turns out that the paradigms that are driving pathology and digital pathology and remote pathology outside of most of North America, or even say outside the United States, those drivers seem to be somewhat different, significantly different. And so assumptions that we make about the marketplace outside of North America and outside of the United States don't actually play as easily within these more highly regulated environments.
So what are the differences? Is it the regulation or other directions of where the needs of pathologists are?
It has, so there are two things. One is the regulation is such that HIPAA is a relatively new thing still, and United States healthcare just has this really clunky way that they tend to embrace new things. Okay, so HIPAA suddenly becomes this set of handcuffs that all of a sudden, and we have to get approvals from various level of IT, and some of the logic makes sense, and some of the logic doesn't make sense, and so on. So you have that portion. Everybody has to deal with it, and that's the way that it is. The second thing is that I think regulation. I'm not sure. I'm still coming back, but I think regulation or something has made United States and North American pathologists less eager to embrace digital pathology. And so the combination of those two things make this marketplace different. Even in Canada, digital pathology is, hey, let's go.
I worked in Canada, in Montreal, for over a year. And they have fully digital hospitals. I met them at US conferences, and they're talking about things that are not happening in the US unless you really are very invested into that. But they
And
also
so
have.
two of my early placements, two of my early evaluation placements are in Ontario, frankly, because they're
They
kind of
have remote pathology networks,
exactly.
and I guess because they have plenty of remote places. So does Norway, where they also adopted telepathology as the first country in the 80s, early 90s. But yes, you're right, totally different mindset, and things are allowed that here people are still very cautious about.
And I think also, and here's me, image guy, scientific products guy. Okay, I think the industry ourselves, or industry as it existed, is also it thinks in a direction like this. Let's try to take what the pathologist is doing, put it on a platform that they're not accustomed to, okay, and then try hard to replicate what the microscopy experience is, okay? So try to replicate what they already can do on a microscopy platform. How about we do things for the pathologist that they can't do, okay, that haven't been done, and create the pull-through, okay? Wait a second. I had, honest to goodness, yesterday in a conversation, I had a hematopathologist say, "Are you kidding? You process 800,000 white cells in a bone marrow smear while I'm watching it?" I'd say, "Yeah, we do 5,000 cells a second." That encourages a pathologist to say, "Wait, I want to go do something new." Okay, I'm not trying to replicate my microscope experience. I want to do something I can't do.
This probably refers to the AI algorithms that you have in the scanner. What do you have there? What solutions do you already have that are ready to be purchased? I assume they come with the scanner, or you can get them with the scanner.
Yeah, at the moment we're being generous because we're packaging them all in a single price. Anyway, it's very attractive. I mean, there's no maintenance agreement. There's no software for the first year. It's just here's your system. But anyway, we have particular emphasis on hematology and pathology, and there's a good reason for that. If you don't mind me expanding.
Go
So
ahead.
let me talk about our founder, Yin. He was a technology lead in a company called Cytogen. It's spelled with an X, Itogen. So Cytogen from Suzhou produced flow cytometers. And so Yin spent several years developing flow cytometers for Cytogen. And Cytogen was eventually acquired by Beckman Coulter for pretty good money a few years ago. But that's where Yin developed this whole concept of flow cytometry is taking single cell images at very low resolution on different wavelengths. What could happen if you had full resolution on those cells and did image cytometry on these images? And that's why the CSFA 800 is called the image cytometer. And that's what's been driving this. So the AI first was developed for hematopathology, obviously, because that's the direction that we began with. Cytology is included of various flavors. And then, so we're working on different solid tissue applications. I have a partnership going right now with an Ivy League university where they're investigating virtual IHC on tissues. And there are a lot of places to go with tissues. It's not as clear as cytology or pathology. So we would like to recruit pathologists and groups and universities to work on this with us in our open architecture to come up with community-based or community-driven solutions. That would work great for us.
This is fascinating. And is there anything else that I forgot to ask you and you would like to tell the listeners?
I've said a lot. I think that the key issues are, number one, the core technology is only limited by the data transfer rate. So we're now up to a 9 megapixel camera that can do 290 frames per second to bring that scanning speed even further down. So we think the technology is going to be durable for a long time as that goes. We think that making this accessible to people in an inexpensive way, in an open architecture way, in a way that's easy to set up and to maintain is the wave of the future. I guess I've said all that, so I don't know if I can add any more.
Thank you so much. Thank you for joining me for this interview, for letting the listeners know about this innovative technology. Where can we find you online?
You can find us at BioInnovation. Just Google BIO onovatation.com. We're there, and we're all over LinkedIn.
Okay, I'm gonna put the website in the show notes. Thank you so much for joining me, and have a great day.
It's a real privilege. Thank you.
Thank you for listening. For more great digital pathology resources, visit the Digital Pathology Consulting website and subscribe to our newsletter on digitalpathologyconsulting.com. After subscribing, you will get access to the free digital pathology crash course, which will help you start working on your digital pathology projects immediately. Talk to you in the next episode.